Okay, PHM 165. We're going to do the math problems for Chapter 6. Okay, so number 6. If there's medication order for ampicillin 500 milligrams and sodium chloride 0.9%, 50 mLs, and you want to give it over 20 minutes, what will be the rate of the infusion? So the rate of the infusion is based on an hour, which is 60 minutes. So we're going to say we're going to give 50 mLs over 20 minutes equals how many mLs over 60 minutes, and that's going to give us our rate. So 50 mLs times 60 is 3,000 equals 20 times the x gives you 20x. We're going to multiply both sides by 20. Okay, so that's going to give us 150 mLs over 60 minutes, or 1 hour. So that is our rate, 150 mLs over 1 hour. So number 13, you need to make 2.5 liters of dextrose 10% using dextrose 50% and sterile water. Okay, so first we know that 1 liter equals 1,000 mLs. Okay, so we're going to figure out how many mLs is in 2.5 liters. So we're going to do a ratio and proportion. 1 liter over 1,000 mLs equals 2.5 liters over x. You're going to cross multiply, and so that's going to give us 2,500 mLs that we need to make. All right, so how much of each will you need? Okay, so let's do our alligation. The highest concentration goes in the top left corner, so that's 50%. The smallest concentration goes in the left lower corner, so that's 0%, it's sterile water. Okay, what we want to make goes in the middle, and so that's 10%. Okay, then we take our 50%, subtract 10, and that gives us 40 parts. So 10 minus 0 is going to give us 10 parts. Okay, and you can look and see how the arrows are going there. So total parts is going to be 50. Total mLs is 2,500. So we're going to say 50 mLs over, 2,500 mLs over 50 parts equals x mLs over 10 parts to get. So we're trying to figure out how many mLs is in this 10 parts right here. Okay, so when you cross multiply, you're going to get 25,000 equals 50x. Divide both sides by 50, so that's going to give you 500 mLs. Okay, so the 500 mLs is going to correlate with the 10, which correlates with the 50%, so it's the dextrose. Okay, so because we know that the total quantity is 2,500 mLs, we can subtract 500 mLs from 2,500, and we'll know that the remaining is going to be 2,000 of water. If you wanted to, you can also do it like this right here. Step 3, again, our total volume is 2,500 mLs in 50 parts equals x over 40 parts. We're going to cross multiply. Okay, get the 100,000 over 100,000 mLs equals 50x. Divide both sides by 50, and that's going to give you 2,000 mLs. So it gives you 2,000 mLs is the 40, correlates with the 40 parts, which go this way, and that's the water. Okay. So the answer is B, 500 mLs of dextrose 50% and 2,000 mLs of sterile water. So number 14. So let's see. Okay, so if 5-fluorouracil comes in 500 milligrams per 10 mLs, and you need to prepare a large volume parenteral for infusion, okay, with 2,000 milligrams in 500 mLs, what will be the overfill volume? Okay, so this is actually going to be on page 159 through 160. And if you look at that table, it's going to tell you that 500 ml bags contain 30 mLs of overfill. So we need to figure out how many mLs of the 5FU or 5-fluorouracil we're going to add to the bag too. So we're going to say 2,000 milligrams is what we need to figure out. How many mLs is in that 2,000 milligrams right there? So 500 milligrams per 10 mLs in our vials equals 2,000 milligrams over X mLs. Okay, so 2,000 times 10 gives you the 20,000, and then 500 milligrams times X gives you 500X. We're going to divide both sides by 500, and that's going to give us 40 mLs of the 5FU or 5-fluorouracil. So we know that we have 30 mLs of overfill already in our 500 ml bag. We're going to be adding another 40 mLs. Okay, so the total volume for that bag is going to be 500 mLs plus your 30 of overfill plus the 40 of the drug. So it would be 570 mLs total in that bag. Okay, so step 4 there. They're saying that this particular hospital says that they have a 10% rule. So if it's more than 10% of the total volume, then you have to withdraw fluid from the bag. So we're going to find out what 10% of the 500 is. So 10% times 500. So we're going to move that decimal place 2 places to the left on our 10% to get 0.10 times 500 gives you 50 mL. So if you have to add more than 50 mLs, or if it's a total overfill volume of more than 50 mLs, then you're going to need to remove fluid from the bag. And this particular hospital says that you have to remove the overfill and the drug volume. So that's going to be 70 mLs. So we're going to have to remove 70 mLs from the bag before we add the 40 mLs of drug. Okay. Okay. So this particular question, the overfill volume, the total overfill would be 70 mLs. Really, you could interpret this question differently in that they're just asking you the overfill volume of the 500 ml bag, and that would be 30. But if you want both of the drug and the overfill, it's 70. Okay. Alright, so number 15, what's the concentration in grams per ml of the final CSP, in which 500 milligrams of methylprednisolone is mixed with 250 ml of dextrose 5%. Okay, they're asking this in grams per ml. We're going to be figuring it out in milligrams, so once we get the milligram quantity, we need to convert that to grams. So we have 500 milligrams in 250 mLs equals how many milligrams in 100 mLs? That's going to give us our percentage because it's based on 100. Okay, when you multiply that out, 500 times 100 gives you 50,000 equals 250x. Divide both sides by 250, so that's going to give us 200 milligrams. Okay, so let's convert 200 milligrams to grams. We know that 1 gram equals 1,000 milligrams. Okay, so equals x grams over 200 milligrams. Okay. Alright, so when you cross multiply that, it's going to end up giving you 0.2 grams in 100 mLs. And percentages is grams per 100 mL, so we're just going to leave 0.2. That is going to be our answer, B, 0.2%. Okay, 16, what is the powder volume of ceftriaxone 1 gram? Vial is mixed with 3.4 mLs of lidocaine 1% as a diluent for the final concentration of ceftriaxone 250 milligrams per ml. Okay, so we remember 1 gram equals 1,000 milligrams. Okay, sometimes we mix our Rocephin antibiotic with lidocaine if we're going to give it IM, so it doesn't, it's not so painful. Okay. So if the final concentration is 250 milligrams per 1 ml and we know that it has 1,000 milligrams in the vial, then we make a ratio here. 250 milligrams over 1 ml equals 1,000 milligrams over X. Okay, so that's going to give us 1,000 equals 250X. We're going to divide both sides by 250. So that's going to give us 4 mLs total volume. So when you take your lidocaine and you add 3.4 mLs of that lidocaine to your vial, you're going to end up with 4 mLs. So how did you do that? Where's the extra volume? Well, it's the powder. The powder has volume. So 4 mLs minus 3.4, that's going to give you 0.6 mLs of volume from the powder. Okay, so C. Number 17, a TPN requires 120 milliequivalents per liter of sodium chloride. You're making a 3-liter bag, 3-liter bags. How much sodium chloride 4 milliequivalents per ml would be needed for each bag? All right, so we have our vials, our stock vials of sodium chloride are 4 milliequivalents per 1 ml, and we need 120 milliequivalents per liter. So we're going to find out how many mLs do we need to get 120 milliequivalents. So you set up a proportion, cross multiply. It's going to give you 30 mLs of sodium chloride to equal the 120 milliequivalents, and that is per liter. And we're making 3 liters, so we're going to multiply that times 3 to give us 90 mLs per bag, per 3-liter bag. So D. What volume in 1 day will a patient receive of lactated Ringer solution running at 80 mLs per hour? So number 18, we know 1 day is 24 hours, and we have 80 mLs going over 1 hour. So how many mLs is going to go over 24 hours? Okay, when you cross multiply, you're going to get 1,920 mLs over 24 hours, so B. So if a patient receives 500 mLs of normal saline in the emergency room over 3 hours, what is the rate of the infusion? So it's 500 mLs over 3 hours equals how many mLs over 1 hour? Okay, so we just cross multiply. You're going to get 166.7 mLs per hour. So C. At what time will the next liter, which is going to be 1,000 mLs of TPN, be needed if a liter is started at 8 a.m. and is running at 100 per hour? Okay, so how long will 1 liter last if it's going at 100 mLs per hour? All right, so 100 mLs per 1 hour equals 1,000 mLs over X hours. Okay, and we cross multiply. 1,000 equals 100X. We're going to divide both sides by 100 and get 10 hours. So 1 liter is going to last 10 hours. All right, so if we started at 8 o'clock, add 10 hours, it's going to give us 1,800. That's when the next bag will need to be hung. And if you wanted to convert that into regular time, you just subtract 12, and it's going to be 6 p.m. So there is B, the answer is 6 p.m. Using a macro drip tubing of 10 drops per ml, what will the drip rate be for vancomycin? 1 gram into 250 ml of normal saline that needs to run over 1.5 hours. So let's convert our 1.5 hours to minutes, okay? Because we know our answer is going to be in minutes. So that's going to be 90 minutes. Okay. Then we're going to say we have 250 mLs over 90 minutes. Okay, so just divide 250 mLs by 90 is going to give you 2.78 mLs over 1 minute. Okay, so then we just have to figure out how many drops is in our mLs. So 10 drops is in 1 ml. So how many drops is in 2.78 mLs? Cross multiply. So that's going to give you 27.8 drops. Okay. 27.8 drops. Then, so you just plug that in. It's going to end up being 28 drops per minute. Okay. Okay. Let's see here. Alright, that's the next page, which didn't have any calculations, so we will move on to the next one. I'll go ahead and show you these answers too, just in case you need those. Okay. Okay. This is a page that starts out with 35. Okay. Okay. So number 40, calculation there. You need to make two 500 ml sterile LVPs of 3% sodium chloride and 5% sodium chloride and normal saline. How much of each will you use per bottle? So remember, normal saline is 0.9% sodium chloride. Alright, so we're going to set up our allegation. The largest percentage, top left corner, 5%. Smallest percentage is a 0.9% to make a 3%. And 3% goes in the middle, so then we're subtracting. 5 minus 3 gives you 2. So that's 2 parts. And 3 minus 0.9% gives you 2.1 parts for a total of 4.1 parts. And we're going to have a total of 1,000 mLs. So 4.1 parts is going to be equal to 1,000 mLs. So let's find out about the 2 parts equals how many mLs. Okay, so the bottom right here. So this 2 parts is going to correlate with this part, the 0.9%. The 2.1 parts is going to correlate with the 5%, how many mLs we need of each of those. So you just cross multiply down at the bottom here. Okay, so 1,000 divided by 2, 1,000 times 2 gives you 2,000 equals 4.1x. We're going to divide by 4.1 each side. So x equals 487.8 mLs of the 0.9%. And then we are going to have two 500 ml bags, so we're going to divide that by 2 to find out how much is in each one. So 240 mLs of the sodium chloride. So remember, 2 parts. I'm sorry, it's hard to remember. 2 parts here goes with that one. So the 0.9% is 244. Okay, and then over here, again, we're going to take our proportion of the 4.1 total parts over the 1,000 mLs total volume equals 2.1 parts over x. We're going to cross multiply. 2.1 times 1,000 gives us 2,100 equals 4.1x. Divide by 4.1 each side, and that's going to give you 512.195 mLs. Okay, that correlates with the 5%, and we are going to divide it by 2 because we have 2 500 ml bags, and so the answer is C. Okay, I hope that helped, guys. You can email me if you have any questions, and I will see you on Tuesday.